Hello everyone, welcome to my channel. In this video I have one integral that I would like to look at, and that's the integral of the square root of 2x minus x squared dx. We are to evaluate this. Now where do we start from? We're looking at the expression under the squared sign. You see that that is a quadratic expression, and therefore completing the square of this would be the starting point, because if you try to differentiate this, you're going to find 2 minus 2x. And we don't have 2 minus 2x outside there to go with the dx, and therefore completing the square of this would be the starting point. Let me show you how that one is done on a separate page. Let me move this one aside. On a separate page, I'm basically saying that we're completing the square of the square root. I hope you can see what I'm writing here. The square root of 2x minus x squared, and we're interested in that. So basically I'm saying 2x minus x squared, completing the square of this. The starting approach would be to factorize, take minus 1 out, and minus 1 into 2x is minus 2x, minus 1 into minus x squared is positive x squared. Why are we doing that? Because we want to write it in standard form, which is x squared minus 2x. Now, completing the square of this, what we need to do is to go through the 3 steps. Step 1 is to take the coefficient of x, which is minus 2 divided by 2. The answer is minus 1. In step number 2, we take minus 1. We have to square it, and the answer is 1. In step number 3, we're going to add and subtract, because we don't want to change this expression. So what basically I'm saying is we have outside here we have minus 1. Inside there we have x squared minus 2x plus 1 minus 1. And so what we need to do now is to factorize this part. So we have minus 1 outside. Factorizing this part, completing the square here allows us to write this as a square of a bracketed expression like so. And then we have minus 1. Try to expand this, you'll get this expression here. Now we have to remove the square brackets. We're going to have minus x minus 1 all squared plus 1, which if we rewrite this, it will be, if I write it up there, it will be 1 minus x minus 1 all squared. This is exactly this part here. Writing positive 1 first, you get that. This is the expression we need under the square sign, as follows. Now, so basically I'm saying that under the square sign, we must have that. So our step number 1, taking us to page 1, I'm basically saying, let's capture the integral of the square root of 2x minus x squared dx. This one simplifies to, like I told you, the integral of 1 minus x minus 1 all squared dx. At this stage, trig substitution should come in, and we're specifically looking at sign. So what are we saying? Basically, we're saying at this stage, we're going to let sine of theta be equal to x minus 1, this part here. And therefore, you can agree with me that this is the same as x minus 1 all over 1. Why am I writing it like this? Because if we define theta in a right angle triangle like this, and that one being our theta, sine would be the opposite side over the hypotenuse side. So that would be x minus 1, and this would be 1. And to work out this side here, we have to use Pythagoras theorem. As follows, I want to show you just briefly. Basically, I'm saying we have a triangle like this, and that's our theta, and that's our x minus 1, that's our 1. Let's say this is a. We want to work out what a is. So finding a requires us to use Pythagoras theorem. Let me just move this one up. So basically I'm saying a squared plus x minus 1 all squared. The answer is 1 squared. Pythagoras theorem, or theorem of Pythagoras. So a squared, this part here moving to the other side, you're going to get 1 when you square that, minus x minus 1 all squared. And if you agree with me, the value of a then is going to be the positive square root of this. We're taking actually the positive square root of x 1 minus x minus 1 all squared. This expression here is just the original expression, if you agree with me, 2x minus x squared, because we had to complete the square of this to obtain that. So I'm going to leave it in this form. So that's the value of a. It must come here. And therefore, coming back to our integral, basically I'm saying now that this part here is supposed to be the square root of 2x minus x squared, like that. Now, in order to determine the expression for the x, we have to differentiate both sides of this. Right. So what are we saying then? We're saying derivative of sine theta is cos of theta, and we're going to say the theta. On the right hand side, there we have dx minus 0, because derivative of 1 is 0, 1 being a constant. Now we have the expression for dx. So this integral then changes as follows. It changes to the integral of the square root of 1 minus sine squared theta, and outside here we have cos of theta d theta. Fantastic. Now we have to work on this part here. It requires us to use another trig identity. Now, the trig identity we're going to use is the following. Let me get a separate page here, and let me move this one up. We're going to use the idea that sine squared of theta plus cos squared of theta, the answer is 1. Solving for cos squared of theta, you agree with me that the answer is 1 minus sine squared of theta. That means where I have this one here, I must place this one. In other words, this integral now changes. The expression under the square sign must be replaced by cos squared theta. So now what we have is the following. We have this integral taking us to page 2. The integral now changes to, let me move this. Yeah, the integral now changes to the integral of the square root of cos squared of theta. Outside we have cos of theta and d theta. Now you agree with me that this cancels that. So now we have the integral of cos of theta times cos of theta d theta. And you agree with me that this is the same as the integral of cos squared, not sine. Cos squared theta. Let me remove this part here. My hand misbehaved there. So now we have the integral of cos squared theta. And then we have d theta there. Let me fix this up. I can write it a bit fast. So cos squared theta d theta, that's what we have. Now, again, this part here is a problem. It requires us to use another trig identity. Which trig identity? Well, double angle formula for cosine. So cosine of 2 theta is equal to 3 expressions. Cosine squared of theta minus sine squared of theta. The other expression is 2 cos squared of theta minus 1. And the last one is 1 minus 2 sine squared of theta. Now, we're going to take this part here. Why? Because we have cos squared of theta here. So we need this part. And what we need to do is to make this subject of formula as follows. So we're going to say cos of 2 theta is equal to 2 cos squared of theta minus 1. Adding 1 on both sides, we're going to have 1 plus cos of 2 theta equals 2 cos squared of theta. Dividing by 2 both sides, we're going to have 1 plus cos of 2 theta all over 2 equals cos squared of theta. So that one here must be replaced by that. Now our integral therefore changes to, let me go back to our integral there. This integral changes to the integral of 1 plus cos of 2 theta all over 2, and then we are saying the whole of this d theta outside there. Now, rewriting this, taking half out, being a constant, 1 over 2, the integral of, let me use brackets here and say 1 plus cos of 2 theta, and what are we saying? We're saying d theta, like that. Now, I'm going to have to distribute the integral sign and d theta keeping half still outside, 1 over 2, and bringing the bracket out. It's going to be the integral of 1 d theta plus the integral of 2 integral of cos 2 theta d theta. Let me rewrite this part here. Cos 2 theta d theta. That's what we're talking about. Now, so that means that we now can evaluate each one of these integrals separately. Now, as follows, let me take this to page 3. Going to page 3, what we have there is, let me move this one down. All right, there is page 3, and we're basically saying that integral changes to, I'm going to keep the half out. The integral of 1 with respect to theta is theta, plus the integral of cos 2 theta is sine of 2 theta all over 2, like that. This being an indefinite integral, we're going to say plus c. Now, I'm going to explain to you how this one here, cos 2 theta, produces sine 2 theta over 2 when we integrate it. But let me just first of all remove the brackets here. So we have 1 over 2 theta plus 1/4, because we're saying half times half, 1/4 sine of 2 theta, then plus c. Now we will continue with this, but let me first of all show you how the integral of cos 2 theta d theta produces sine 2 theta over 2. We basically use u substitution as follows. So the integral of cos of 2 theta d theta, basically we let u be equal to 2 theta, and therefore du equals 2 d theta, divided by 2 both sides, du over 2 equals d theta. This integral therefore changes to the integral of cos of u du over 2. Remember, theta 2 theta has been replaced by u, and d theta has been replaced by du over 2. Take half out, because half is a constant. The integral of cos u du, and what is the integral of cos u? Well, it's sine u, so this is half of sine u. But what is u? U is 2 theta, so this is just half sine of 2 theta. That's how we get this that's how we get sine 2 theta over 2 from cos 2 theta d theta. The integral of that gives us that, because of that simple trick there of u substitution. Now, so at this stage, we're going to look at double angle formula for sine. Let me keep this one as it is. So this is going to be equal to 1 over 2 theta plus 1/4 times 2 sine theta cos theta plus c. That's double angle formula for sine. That produces that part there. But we have 1/4 out, so this cancels there. 2. Now what we have is 1 over 2 theta plus 1 over 2 sine theta cos theta plus c. Now we need to go back to our original variable, because theta is not our original variable. So we need to go back to our original variable. That takes me to page 1. Looking at page 1 here, you see the relationship between theta and x is that sine theta equals x minus 1. And therefore from here you can agree with me that theta is going to be sine inverse, or some people say arc sine of x minus 1. So where I see theta, I must put this expression. So coming back here, this is going to be half of sine inverse of x minus 1 plus half. What is sine theta? Well, sine theta is x minus 1. So I'm going to have x minus 1. What is cos theta? Well, if you look at this triangle here, cos theta is just going to be this expression over 1, which gives us this expression, square root of 2x minus x squared. So I'm going to have square root of 2x minus x squared. And then I must say plus c, because we're dealing with an indefinite integral here. So this would be our final solution. A little bit of patience required in terms of processes involved, but otherwise, yeah, there's nothing special about this integral. One had to just be patient with Trig substitution and using double angle formula and a simple trig identity of sine squared plus cos squared equals 1, we have been able to show that this is the final solution from our integral in this video, which is basically this one here. So these are advanced cases of U substitution together with trig substitution. So very, very important. I hope this will help somebody. If you're new to the channel, do not forget to subscribe. I'll see you in the next one.